In this video, we're going to look at a trigonometric integral after applying a trig identity. So we want to evaluate the integral of dx over cosine x minus 1. Now at first glance, it doesn't look like there's a lot we can do, but we can do a little bit of a trick here that allows us to see an identity in the denominator where we can actually rewrite the integral into something that we recognize. And that trick is multiplying the top and bottom by the conjugate of what would be essentially the conjugate of the denominator. So we've got a cosine x minus 1, so the conjugate idea would be replacing that minus sign with a plus sign and multiplying top and bottom here by cosine x plus 1. When we multiply out the denominator, we get cosine squared x minus 1. That looks a lot like the 1 minus cosine squared x. In fact, it's the exact opposite. 1 minus cosine squared x we know is equal to sine squared x. So this denominator is actually equal to the opposite of sine squared x. So now we have the integral of cosine x plus 1 over negative sine squared x dx. We have a plus sign in the numerator, so we can break those fractions into two pieces. Well, break that single fraction up into two fractions. So write it as opposite of cosine x over sine squared x minus 1 over sine squared x. Notice we can break this now into two pieces because we got the plus sign on top. We could not break it into two pieces originally because the minus sign was on bottom. Just to see what these functions look like in rewriting them, I can rewrite this as cosine x over sine x times 1 over sine x. Still got the 1 over sine squared x here on the end, but we recognize cosine over sine as cotangent and 1 over sine as cosecant. So now we're looking at taking the antiderivative of negative cosecant cotangent minus cosecant squared, x dx. Antiderivative of negative cosecant cotangent is simply cosecant, and an antiderivative for negative cosecant squared is cotangent.